Hi students, in this video we're going to learn how to recognize similar triangles and the test that we need to conduct to verify if the pairs of triangles given are similar or not. Right, basically there are three tests for similar triangles. The first one is all pairs of corresponding angles are equal. The second one is the two ratios of the corresponding sides and the pair of included angles are equal. And the third one are the three ratios of the corresponding sides are equal. Right, not to worry, we will be doing some examples, right, that we can apply this test. All right, so let's recall the three tests that we have learned just now. The three tests, the first one is all three corresponding angles are the same, right? So all three corresponding angles are the same, meaning if you're given two similar triangles, then we're just to make sure that the three angles, okay, must be the same. That it means that's what you mean by three pairs of corresponding angles are the same. Then the second test is that if you have two similar triangles, you're given two corresponding sides. Okay, two corresponding sides. And then the included angle. Right. If the ratio of the two corresponding sides and the included angles are the same, then the two triangles are similar. Okay, then the last one will be three ratio of the corresponding sides must be the same. So the last one is you must be given all the three sides. Right, so it's quite easy to remember. So if you look at this example one that I've given to you, right, which categories do you think it will fall into? Is it the first one? Is it the second one? Or is it the third one? Yes, it will be the second one. Why? Because you're actually given two sides and one included angle. So where are the two sides given to you? So to look out for the two sides, you just look out for a big tree sign, a V shape. A V shape. So if you look at the first triangle, the V shape is there. Can you see? Second triangle is the one that's highlighted in yellow. Okay? And the angle that is wedged in between will be your included angle. So in this case here, the included angle is 60 degrees. And then for the second triangle, it's also 60 degrees. Okay, so how do you go about proving that these two triangles are similar? So we have to first of all compare the ratio of the first pair of corresponding sides. Okay, so yeah, there are three sides there, right? PQ are the three sides. So PQ happen to be the shorter sides. So you compare the shorter sides of your first triangle with the shorter sides of the second triangle. So the shorter sides of your first triangle is PQ here. Then you compare with the shorter sides of the second triangle, which is XY. Okay, so let's do it. QP over YX. So that gives you 3 over 6. That gives you half, right? So that is your first ratio. Right, then you go on to compare the next sides that's given to you. That's the longer side, which is QR. And you compare it with YZ. And you also get half. Right. So that means we have two ratios of the corresponding sides are the same already. Very happy. Now let's verify if the included angles are the same. And of course, they are the same from the diagram, is 60 degrees. So angle PQR is equals to angle XYZ equals to 60 degrees, given in the diagram. Okay, I need to erase this because I'll be writing some statements over there. So therefore, we can conclude, okay, that triangle QPR is similar to triangle YXZ using two ratios of the corresponding sides and the pair of the included angles are the same. So therefore, they're similar. Okay, and in the Singapore O-level syllabus standard, you have to write all this out. Okay, right, you have to write out, spell it out in full, saying that two ratios of the corresponding sides and the pair of included angles are the same. Okay, and when you name that the similar triangle, you make sure that the angle corresponds. That means your angle Q will correspond to angle Y. Your angle P must correspond to angle X. Correspond means must be the same angle. Angle Y must correspond to angle Z. So the order is important. Right, let's look at the next question. So the next question is you're asked to find the two unknowns H and K. All right, find H and K in the two triangles. So before we can actually go about using the concepts of similar triangle, we have to prove that they are similar. Okay, we have to prove that they're similar before we can actually go about comparing the ratio. Right, so there are three tests. There are three tests to prove that those triangles are similar. The first one is all pairs of corresponding angles are the same. Second one is the ratio, the two ratio of the corresponding sides and the pair of included angles are the same. Then the third one is the three ratios of the corresponding sides are the same. So in this case here, if you look at it, you're only given the values for two sides. Okay, this value, two values. So supposing if you want to use the ratio of two sides and the included angle, right? Okay, let's look for the V sign, the victory sign. So here, this is a victory sign, right? Okay, and for the other triangle, this is a victory sign, right? Right. So we are given the two sides there, but then we have to make sure that the included angles are the same, right? If you look at the first diagram, the included angle is two lines. But in the second triangle, the included angle is just one line like that. That means they're not the same. They're not the same. Okay, so we can't use the second one to prove that they're similar. Okay, so we can't do that. Then the next thing is that let's see if we can use a ratio of three corresponding sides. Three corresponding sides, because you're given all the three sides, right? So let's see whether, very chuan. Let's see whether we can do that. But then you realize that we can't lay. Why cannot? Because K is an unknown and H is also unknown. So you can't really find it. You're given the sides, but it's an unknown. So you wouldn't know the ratio, right? Right? If you want to use the ratio, it must be a value. You know, it must be like half, 3/4, 6/10, the kind of thing. It can't be an unknown over a value. Okay, so I can't also use the three ratios of corresponding sides are the same. So therefore, I can only rely on which one? Yes, you can only rely on the corresponding the three angles, the three corresponding angles are the same. Okay, so let's go on to prove it. So let's have the first angle. Oh, okay, let's compare the sides first. Of course, the second shorter side of the first triangle compared with the second shorter side of the second triangle, and then the longest one compared with the longest one, then the shortest one compared with the shortest one. Okay, so if you have a highlighter, it's very useful when you are doing similar triangle, congruent triangle. Having the highlighters, a few highlighters are very useful. Okay, right. So let's go on to prove that the corresponding angles are the same. All right, so angle CAB is equals to angle RPQ. It's given in the diagram there, given in this diagram here. Okay, and then the another pair of angles are the same, also given in the diagram. Right. And of course, if two corresponding angles are the same, then the third one will be the same based on angle sum in the triangle. So therefore, you can say that the two triangles are similar using all pairs of corresponding angles are the same. Okay. And let me repeat again, in Singapore context, you will really have to spell out all the words. Okay, you have to spell it out in full. That triangle ACB is similar to triangle PRQ using all pairs of corresponding angles are the same. Spell out in full. Alright, so once you know these two triangles are similar, we can just compare the ratio of the corresponding sides. So the blue color compared with the blue, right? And then the yellow, oh, not the yellow, the pink, AB over PQ, right? So we do a cross multiply, and you get K equals to 6 centimeter. Then we go on to compare the yellow with the yellow, right? And then AB with PQ. So do a cross multiply again, and you end up getting H to be 32 cm. So that's how you find the unknown H and K. Right, let's look at some important angle properties that are necessary when you solve problems with similar triangles. And it usually involves parallel lines. Yes, similar triangle usually involve, you will be given some similar triangles, and usually there'll be a lot of parallel lines, okay? And then, so we need to recap some important angle properties that involve parallel lines. So the first one, it's remember your corresponding angle. Right. Can you remember the second one? Yes. The alternate angle, look out for a Z symbol, the A, B, C, D, E, F, G, blah, 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 the last letter, X, Y, Z, Z, look out for the Z symbol. All right, so angle C is equals to angle D using alternate angles. And then the last one will be interior angle. But interior angle, we seldom use it. Most of the time, we use corresponding and alternate angles. Oh, another one is the vertically opposite. But vertically opposites are not under the category of parallel lines. Okay, so do remember these three different angle properties. These three different angle properties is also very useful when you solve questions on bearings. Okay. Right, so let's look at another question. So in this question here, you're supposed to prove that triangle PAB is similar to PQR. Right, so like what I've mentioned earlier, can you see a pair of parallel lines there? Ah, yes, AB is parallel to QR. Yes, AB is parallel to QR. Okay, right. So we need to prove. So we are already told that triangle PAB is parallel to PQR. We just need to prove it. So to prove it means we need to write down some proper statements. Okay, so in this case here, we have three tests, remember? We have first test as all corresponding angles are the same. Second one is ratio of two ratios of corresponding sides, and the pair of included angles are the same. And the last one is the three ratios of corresponding sides are the same. So which one do you think it's appropriate here? Yes, we'll be using corresponding angles are the same. Okay, remember the parallel lines I told you? So we'll be using what kind of angle property? You can't see any Z sign there. There's no interior angle, so obviously we have to rely on corresponding angle. Okay, so angle PAB is equals to angle PQR, corresponding angle. Yes, and we have a common angle there. APB is equals to angle QPR. When you say common angle means like I have it, you also have it lah. So it happens in APR, it also happens in QPR. So that's what I mean by common. And of course, you can also use angle sum. The last angle will be the same, which is angle sum in the triangle, or you can also use angle PBA equals to angle PRQ. Same thing, corresponding angle. So therefore, the two triangles are similar using all pairs of corresponding angles are the same. All right, so that's part A. So once you know they're similar, we can just compare ratio of the corresponding sides. Okay, so ratio of the corresponding sides, we can compare PA over PQ. You asked to find the length of AQ. Okay, there's one common mistake that some students may make. So I'm going to tell you what is a common mistake. Some students will just go ahead and use PA over AQ equals to AB over QR. Right. Okay, so why is this wrong here? Okay, PA belong to this triangle, the smaller triangle, right? PA belong to the smaller triangle. So that's fine if you want to use PA, because we're talking about similar triangle, so it has to be a triangle, right? So PA belongs to the sides of a triangle, that's fine. But then PQ does not belong to the sides of a triangle. It belongs to part of a triangle. In fact, it belongs to a trapezium. This is a trapezium. This one here is a trapezium. This one is a trapezium. Right. So therefore, this is wrong. Okay. When you want to compare sides of the similar triangle, the sides must belong to a triangle and not to the trapezium or parallelogram. So in this case here, the correct way, if you want to write it, the correct way is PA over PQ equals to AB over QR. Okay, so just take note of that. It's very important. Don't make this kind of mistake. Alright, so let's continue. Let's continue. So I know PA. Do I know PA? No, I don't know the values of PA. But I know PQ it's 14 and AB is 6. So QR is 10. So we do a cross multiply, we can find PA. Right. And of course, AQ it's PQ minus PA. So which is 5.6 centimeter. Okay. Right, let's look at the next questions. Here in this case here, we see parallel lines, right? Yes, but can you spot the symbol Z? Yeah, there's a Z sign there, here. Right, so in this case here, which angle property can we use here? Correct, we can use alternate angle. Okay, but in this questions here, oh, you're only asked to name the pair of similar triangle. You don't have to prove it, you just name it. So from there, we can see that triangle ABC is similar to triangle EDC. So make sure the angle must correspond. Yep. So angle B must correspond to angle D. So when you name the triangle ABC, you must make sure it's EDC. Yes, and that vertically opposite. Yeah. Correct. Okay, very important. Your angle A must correspond to your angle E. Your angle B must correspond to angle D. And of course, C it's the same, vertically opposite. All right, so once, oh, and you have to write down the reason why are they similar, because you're using, oh yes, just to show you that the AB correspond to ED. Oh, we forgot something. Oh, you asked the name, was it only you name the pair? All right, name the pair only. Okay, that's it. So part B now we know that they're similar. We can just use ratio of the corresponding sides. So we compare DE with BC. Sorry, DE with BA. DE with BA, and then DC with BC. And from there, you do a cross multiply, you will get DE to be 15.75 centimeter. So once you make sure that, right, let's look at the next one. The next questions it's slightly more challenging because the two triangles may not look similar to you. No, in the earlier few examples, right, the triangles do look similar to us. So here it does not appear to be similar, but not to worry, because you're given that in part A, you're asked to prove. That means you're told that the triangle PST is similar to PRQ. All right, so you're already told that they're similar. You just need to write statements to prove that they're similar. Okay, so in this case here, which property do you think you can use? Is it the first one, where all corresponding angles are the same? I don't think so, right? Because from the look of the two triangles there, we only have two angles. Oh yeah, two angles. If two angles are the same, then of course the third one will be the same. Yeah, exactly. So we need to use the three pairs of corresponding angles are the same. Okay, so that's right now the first angle that's the same. Yes, angle PST is similar to PRQ. PST is similar to PRQ. Is given there. Okay, where is it given? It's given angle in the diagram here. Okay, and there's also another common angle here. Okay, right, so angle SPT, S first, right, followed by P, then T, right? So when here will be R first, followed by P, and then followed by Q. Okay, just once you get this correct, okay, once you're given that this triangle is similar to that, right, the order will be the same already. Okay, so it's quite easy already. Okay, of course the third angle will be the same because angle sum in the triangle. So therefore, triangle PST is similar to PRQ using all corresponding angles are the same. So once you know they're the same, then we can use the ratio of the corresponding sides. Okay, so can you see that once you get a hang out of it, once you get the concepts right, you can solve any questions. Okay, they're more or less the same. Okay, so PR over PS equals to PQ over PT. Just fit in the data, find your PR, cross multiply, find your PR, which is 18 centimeter. And then your RT is basically PR minus PT. So it's 18 minus 3 gives you 15 centimeter. Okay, we're still left to find QR. So we can use some more ratio. Okay, we can use QR over TS equals to PR over PS. Okay, basically just compare ratio left equals to ratio right. How do you do the ratio is the small over big, the sides of a small triangle over the corresponding sides of the big triangle equals to back to the another sides of the small triangle over the corresponding sides of the big triangle. Okay, we do a cross multiply and you get QR to be 24 centimeter. Right, having done all the basics concepts, you know, that how to recognize similar triangles, what are the tests you can do to prove that they're similar. Okay, now it's the time for you to to do some questions on your own. So the questions are from assignment 9.3, right? So please try it first, and if you really face problem, then you can refer to the solutions, to my explanations in the next few slides. Right, I'm starting off with question 10 because question 10 is supposed to be one of the hardest of the remaining questions we're supposed to do. You see that it's highlighted in red. It's supposed to be advanced question. I think it's advanced because there's so many similar triangles and sometimes you get confused. You see, you don't know like, which two triangles should I go and use it first? Okay, but don't worry, if you have a clear mind, have enough sleep, drink enough water, you can still recognize the similar triangles. Okay, so in part I, you're supposed to find the length of RT. So if you see that RT actually belongs to the triangle QTU, right? QTU. RT is part of the triangle QTU, right? So that gives an idea that maybe we have to look at triangle QTU first. Anyway, there are two parallel lines, there are three parallel lines, but let's concentrate on R, S, and TU first. So if you look at QRS, you see the triangle there, it's similar to QTU, yes, okay? Right, it's similar using corresponding angles, yes. You can see that angle RSQ, it's angle TUQ. So it's confusing in the sense that, okay, these two angles are the same, right? Corresponding angles. And this one, it's common angle. Okay, of course, the third one will be the same. So therefore, the two triangles are similar using all corresponding angles are the same. So once you know that they're similar, you can just use the ratio. So I can compare QR over QT equals to QS over QU. Sub in the values and from there I can find QT, which is 18 centimeter. Then of course RT will be QT minus QR, right? So that gives you 6 centimeters. So that's quite easy. Finding RT is quite easy. Then the next thing of course is to find PR. So PR belongs to which triangle? Yes, PR belongs to triangle QPR, right? PR belongs to triangle QPR, so we need to focus on the triangle. Okay, right, and you see that we have the two similar triangle. Can you see the Z sign there? TU parallel to PQ. So your angle TUP will be the same as PQR. Right, this angle and this angle, alternate angle. This one is the same as this. And this is the same as this. And we also have the vertically opposite angle. Okay, so TRU is similar to QRP. Using all corresponding angles are the same. Then you can use the ratio. PR over UR is equals to QR over TR. Sub in all the values that you know for QR. UR, QR, TR. No wonder it's advanced lah. All the R and Q and P. Oh my god. So anyway, just do a cross multiply. You can find PR to be 12 centimeter. Okay, so we managed to find the values for R, T, and PR. Okay. Right, so the next part of the question is easy already. Yes, it's really easy because once we find all these unknown R, T, and PR, we can just find the ratio already. Okay, so what's the ratio? Yes, so TRU, where's TRU? So we know that this triangle is similar to QPR. Okay, so the ratio of PQ over TU will be the same as the ratio of PR over UR. So earlier on in part I, we already found the values of PR to be 12 and UR is given to be 6 here. So it's just 12 over 6 give you 2. Right, so you're supposed to write your answer as a ratio, so make sure you write it. You can't leave your answer as PQ over UT equals to 2, that is a fraction. So you need to write it as a ratio, so therefore PQ is to TU, it's 1, 2 is to 1. Okay, 2 is 1, so that's how you do question 10. Right, I'm going to go through very quickly for question 3. Question 3 basically is just to test whether you know how to apply the 3 tests correctly. So you're supposed to determine if the following pairs of triangles are similar or not. So if you look at the first pair, okay, we fill in all the angles. Oh, it happens to be equilateral triangle. All the angles are 60, 60, 60. The second one, you realize that it's 50, 65, 65. So you see that the angles are not the same. So therefore, they're not similar. Okay, so you explain it as such that since all pairs of corresponding angles are not the same, the two pairs of triangles are not similar. So likewise, you do the same for part B. Find all the corresponding angles, and then you see that they're not the same, so therefore they're not similar. Okay, so it's not difficult. All right, let's move on. Okay, so you're given 3 sides, right? All the 3 sides. So of course we should be using the 3 ratios of corresponding angles. Wrong. The 3 ratios of corresponding sides are the same. We should be using that test. So let's compare the shorter sides of the first triangle with the shorter sides of the second triangle. Okay, let's compare the ratio. Okay, never mind. Let's continue to do comparison. The second longer sides of the first triangle with the second longer sides of the second triangle, and then the last, which is the longer sides of the first triangle with the longer sides of the second triangle. So you compare the rate with the rate, you get ratio 4 over 9. Compare the pink with the pink, get half. Compare the blue with the blue, get half. So can you see that all the ratios are not the same? 4 over 9 obviously not equals to half, right? So therefore we can make a conclusion that the two triangles are not similar because the two pairs of triangles are not similar because the ratios of the corresponding sides are not the same. Okay, the 3 ratios. The 3 ratios. Okay, since the 3 ratios of the corresponding sides are not the same, the two pairs are not similar. Right, so the next one, if you look at it, yes, can you see the victory sign there? Yes, there's a victory sign there. Okay, where's the victory sign? Referring to here, right? And that is the included angle, right? And then the other victory sign and the included angle. So in this case here, now let's see whether we can use the second test. The second test is the 2 ratio of corresponding sides and the pair of included angles are the same. Let's see whether if they are. Right, so the yellow compare with the yellow. So that gives you 5 over 2. And then the blue compared with the blue, and that gives you 15 over 7. They're not the same. Okay, so therefore the two triangles, yes, the included angles are the same, but the other 2 ratios are not the same. So we conclude that even though the pairs of included angles are the same, right, unfortunately, the 2 ratio of the corresponding, I think I do too much until I'm confused already. The 2 ratios of the corresponding sides, not angle. Okay, the 2 ratios of corresponding sides are not the same, hence the 2 pairs of triangles are not similar. Okay, let's look at question 7. Question 7 is not difficult at all. The only difficult thing is that you must understand the property of a rhombus. That's very important. If you do not remember the property of a rhombus, then you can't really solve these questions. Yes, a rhombus has 4 sides. all the four sides equal to one another. Yes, rhombus have four sides all equal to one another, and the diagonals actually bisect each other at 90 degrees. Okay, let's look at part I. Although there's no part I, it just asks to find the length of x, y, and wz. Okay, let's see x, y first. Okay, so if all the four sides are equal, then we are saying that VW is 18, XW is 18, UX is also 18. Okay, right. Let's see how we can go about solving it. Let's see what magic I have there. We started with the ratio. So we're given that XU is to U, Y is 3 is to 2. That means I'm going to let XU to be 3 units. It's a ratio, so it could be 9 cm or whatever. So it's just 3 units. Represent it by using 3U. And then UV, UY represented by 2U. Okay, and since UVWX is a rhombus, yes, I've just labeled it for you. All the sides are equal to 18 centimeter. So 3 units is 18 centimeter. So therefore, you find 1 unit to be 6. And if you look at the triangle there, your XY is made up of 3 plus 2 units. That's 5 units. So that will be 5 times 6, 30 centimeter. So finding XY is relatively easy. But of course, that is when you need to know that your rhombus has all four sides equal. Alright, so in the earlier slide, we've already managed to find XY to be 30 centimeter long. Right, we found 1 unit to be 6 centimeter. Right, so 5 units will be 5 times 6, 30 centimeter long for XY. The next thing is that we need to find WZ. Right, so in this case here, we can't run away from having to apply the concepts of similar triangle. So you see that we have two parallel lines there, UV and XZ. So there we can use corresponding angles, right? You can quite clearly see that triangle YUV is similar to YXZ by now. By now, you should be able to recognize similar triangles already. So let's write out all the proper statement. Yes, corresponding angle, common angle, and we can still use corresponding angle again. Otherwise, you can use angle sum in the triangle. So we conclude that the two triangles are similar. So once they're similar, then you can use ratio of your corresponding sides. Oh, sorry, I'm supposed to find exact first. So ignore the last line, ignore the last line. Let's find exact first. So exact is 45 centimeter. Your exact is 45 centimeter. So therefore, your WZ will be exact minus XW. So this one should come out last. This should come out last. Okay. So you should, from here, you should continue here to find exact first. And WZ is XZ minus XW, which is 45 minus 18, because it's a rhombus, so all the four sides are equal. So therefore, your XW is also 18. So it's 45 minus 18 gives you 27 centimeter for WZ. Right, so let's do the last questions. Finally, the last questions. So you're told that there are 3 similar triangles there, and you need to prove that they're similar. Okay, so the first pair of similar triangle I can see is ABD and ACB. Okay, so I'm going to prove it to you why they're similar. Yes, first of all, we can use triangle ABD to find the sides AB. Pythagoras theorem. 3, 4, 5 are very popular, very famous Pythagoras theorem. Oh my God, forget it. Okay, they are just called the triplets. Okay, 3, 4, 5. Another one is what? 12, 5, 13. Okay. So anyway, you can use Pythagoras theorem to find AB, which is just square root of 4 squared plus 3 squared. So the square root of 25, let's give you 5 meter. Alright, so ABD is similar to ACB. So what are the reasons? Yes, angle ADB is ABC equals to 90 degrees. Okay, quite obviously you can see there. And then angle BAD is CAB, common angle. And of course the third angle will be the same based on angle sum in the triangle. So therefore these two triangles are similar. And then there's also another pair of similar triangle, ACB and BCD. Right, ACB and BCD. Why are they similar? So I'm going to give you the reasons again. Right, so basically you see that the reasons I gave are almost the same to prove that they're similar. Okay, that this angle is equal to the angle is 90 degrees. Okay, and that angle equal to that because it's a common angle. So therefore the third pair of corresponding angles will be the same because using angle sum in the triangle. So from there we can conclude, you see, if your ABD is similar to ACB, right, and then the ACB is similar to BCD, then therefore ABD, ACB, and BCD, they're all similar triangle. Oh my God, isn't that confusing? Okay, if you find it confusing, don't worry, you just have to sit down, relax. Okay, you really need to give time to it. As in like, sit down, relax, go through every line properly, why, and then try it out on your own before you can actually appreciate that there are similar triangles. Alright, so once we recognize that who and who are similar, alright, the part 2 is easy already. Okay, find the length of BC and CD. So if you want to find the length of BC, then we will use the first pair of similar triangle we found early on, which is, yes, using triangle ABD and ACB. So actually it's quite, the questions is such that there's quite a lot of scaffolding provided, right? BC, you can see that it happens in triangle ACB, and then triangle ACB, we have proved that it's similar to ABD, right? So we're just going to use this pair of similar triangle, use the ratio. So we compare DB with BC equals to AD with AB, then fit in the data given, do a cross multiply, and you'll get BC to be 6 and 2/3 centimeter. Right. Once you get this correct, like I keep mentioning it many times, right? You see, DB is this direction, right? So it correspond to BC. Okay, can you see? It's very easy. And then AD, right? AD, see, will correspond to AB. So AD will correspond to AB. Okay, so just fit in all the information and you can find BC. Then to find CD, it will use the second pair of similar triangle we found, which is ACB is similar to BCD. So again, we use the ratio thing, BC over DC. BC will correspond to DC, and then AB will correspond to BD, right? And fit in your information again, and then do a cross multiply, and we can find DC to be 5 and 1/3 centimeter. Yes, and this complete the video on how to verify two triangles are similar, all the tests, and lots and lots of examples and practice questions. Okay, so happy learning.